All right, everybody. We are going to do scientific notation with adding and subtracting, word problems, and system of equations. Now, I just am doing this video for a second time, and I want to show you why. All right. This is the first problem. I was walking my way through it. I got all the way down to 17.7 times 10 to the fifth, and I got it wrong. And then I looked and I said, oh man, it's 1.77 times 10 to the sixth. So you see, Mr. Field is going to make that mistake of not putting the number back in scientific notation. So let that be a lesson to you before you start now. Now, let me show you how to do this, okay? And then remind me before we put in the answer, it needs to be in scientific notation. So when we're adding or subtracting in scientific notation, we need same exponents first. Okay, so just like multiplication and division, let's get this standard form into scientific notation. So we know that would be 3.6 times 10 to the 1, 2, 3. 6.3 times 10 to the second, right? But we need the same exponents first. So you see how that's 10 to the third and that's 10 to the second? How could we rewrite this thing so that it was 10 to the second instead of 10 to the third? Well, it has to be 3600 in standard form. So actually, if we wrote 36 times 10 to the second, that would be 36 with 2 zeros minus 6.3 times 10 to the second. And now, in order to solve the problem, we just do the 36 minus 6.3. And then that's 7. I had to borrow, now I have to borrow again. That's 2, so 2, and then that's going to be 9, 29.7. Now, answer is 29.7 times 10 to the second. But wait, we cannot put that in because it's not in scientific notation. We need to make it 2.97 times 10 to the what? Should it be 1 or 3? Let's think about it in standard form in order to figure that out. So 29.7 times 10 to the second would mean we are moving the decimal point to the right 1, 2 spaces. So it has 1 0. We want to choose the option that would give us 1 0. So let's see, if we moved it 1, that would not give us 1 0, that would give us 29.7. We moved it 3 times from 2.97, that would give us the desired 1 0. 1, 2, 3 moves, and so 10 to the third. So 2.97 times 10 to the third. Let's see, 2.97 times 10 to the third. All right, let's do one more. Okay, addition. So as you can see, exponents, they are different. So let's take this 5 and bring it down to a 4. Now you can go either way. You can bring the 4 up to a 5. You can bring the 5 down to a 4. You just need the exponents to be the same. So let's say this one, as it stands, the decimal would move 5 times, which means it has 4 zeros, right? So if I want it to be 10 to the fourth, well, that's 4 zeros all by itself. So I can't have a decimal point that needs to move. I'm just going to need it to be 54. 54 times 10 to the fourth will be 54 with 4 zeros, just like this one has. All right, so now let's just bring the other one down. which is already 10 to the fourth. And now we're going to add our whole numbers here to our rational numbers here together. So that's 6.7. Line up my decimal points. 7, that's 10. 60.7. So 60.7 times 10 to the fourth. I don't dare put that in because it's not in scientific notation. We want to put in 6.07 times 10 to the fourth. Oh, not to the fourth though. What would it be? So we want to move that decimal point 4 times. So that's 1 and 3 zeros. 1, 2, 3. So we need 3 zeros. We're going to need to move it 2 and then 3 zeros. That's a total of 5 moves. So just do your zero analysis, figure out what it should be, and you'll get there. It might take a few tries, but it's practice, right? Okay, now let's talk about the word problems. So with word problems, we may be adding, subtracting, multiplying, or dividing. So we're going to figure out what it is, then we're going to set up that problem and solve it. Then look for our keywords. Okay, so the table shown below gives the approximate number of pieces of mail handled by the U.S. Postal Service for different years. How many more pieces of mail were handled here? So how many more? What do you think that is? You think that is addition, subtraction, multiplication, or division? How many years older are you now than you were 3 years ago? You know, in order to do that, you have to subtract, right? So this is subtraction. We are going to subtract. All right, so we're going to set up a subtraction problem. 1995, 1965. 1.8 times 10 to the 11th minus 1965, 7.2 times 10 to the 10th. I know this one, as it stands, would have 11 moves. That would be 10 zeros because of the one move to get behind the 8. And so if I want to change that exponent to also be a 10, what does that change our number to? Let's think about it. We need 10 zeros, so that's going to have to be 18. All right, that wasn't hard. So now we're going to do 18 minus 7.2. All right, so that'd be 8, 0, 1. So 10.8 times 10 to the 10th. And so 1.08 times 10 to the, what we need, 9 zeros. Oh yeah, it's going to be 11. Right, so I'm noticing the pattern. When I move it over to the left one, I have to add a 0. And I'm sure you'll notice that too. Times 10 to the 11th. And we got it. All right, how many total copies? So we know that would be addition. And so, you know, look for your keywords. If it says how many times more, that would be division, or yeah, figure out the keywords there. Systems of equations. So we're going to be graphing. So, you know, go back to the organizer, look at solving by graphing, solving by substitution, the word problems. And we did that about a month ago, so not too far back. And then give this one a try, all right? Because now that we covered systems of equations, but it's been a little bit, you've probably forgotten some things. Gives you a chance to remember that is spacing, and that will help you remember this into the next year when you have to do it again in Algebra 1, because you will. All right, so happy solving. Oh, and post in the organizer once for each assignment.